This circuit you're looking at has the ability to absorb energy from the environment, and that energy comes in the form of radio frequency signals like from cell towers, Wi-Fi signals, and similar sources. It then turns that energy into electricity and stores it in these capacitors, the orange ones you can see here. This is absolutely true, and I'm going to practically show everything in this video. You can see that I've set the multimeter to DC voltage mode, and it's currently showing 0. Now I'm going to connect the circuit to the meter terminals. Red is positive and black is negative. You can already see the voltage going up slowly, and remember there's no power source connected, yet the voltage is climbing. How is this possible? It's because the point you're seeing here is acting like an antenna, absorbing radio frequencies from the air and turning them into electrical energy, which gets saved in these capacitors as DC voltage. Currently, you can see the charge is in millivolts, which isn't much. We have charged it up to 12 millivolts so far. We now need a larger antenna. Since my body also conducts electricity, it can act as an antenna too. So let's try touching it, and now you can see the voltage jumping up quickly. We've already crossed 160 millivolts DC. This happens because the antenna now has a bigger surface area. It also depends on the number of nearby cell towers and how close they are to this circuit. As you can see here, we've reached about 400 millivolts. Let's see how much higher it can go. We've now hit 6 volts and it's still going up. It seems like 1 volt is within reach. Also, remember that some voltage is lost across these diodes. Since multiple diodes are connected in series, there's a bit of drop, but they are essential to convert the AC signal into DC. The charging has now slowed down. I was hoping it would at least go past 1 volt, and as you can see, it's topping at around 889 millivolts DC. Now it's crossing 900, and again increasing rapidly. And finally, we've passed 1 volt, it's still going. Now I'll take my hand away. You should see a drop in the voltage. As I removed my fingers, you can see the voltage dropping fast. And if I touch it again, it starts rising again. Now let me show you my camera stand, and underneath you can see a piece of cardboard. That's there to isolate the stand from the ground. This tripod will work as another antenna. There's a wire here with a clip on one end and just plain wire on the other. The clip side will connect to the tripod as the antenna, and the plain end will be joined to the circuit. Currently, the meter is showing 0 volts DC. Now let's connect the antenna wire, but first, I'll connect these other wires. It's showing 53 millivolts now, so we should discharge it first. As soon as I disconnect the wire, it starts charging again. Now the wire is off, and once reconnected, the capacitors are already charging, 10.8 and going up. Let's now finally attach the antenna wire. This should cause a sharp voltage jump, and yes, there's a fast rise in charging voltage. Let's see how high it gets. Not sure why, but when I touch the wire, the voltage seems to increase even more. No clue why that's happening, but it is interesting. The voltage is now 1.7 volts, and charging fast. We're getting close to 2 volts. That's really cool. Now I'm removing my fingers, and again, the voltage is dropping. At first, I thought maybe a loose wire was causing this, but now I think something else is going on when I touch it. Let's see how far it goes. Nearly 2.5 volts now. Wow. 3.5 volts. And again, when I stop touching it, it starts discharging. Something's going on with my fingers. See, it's strange. Oh, now I understand. My body is connected to the ground, and when I touch this wire, we're getting an AC signal. Here, and this side is ground, so it charges the capacitors faster. It's giving it the right polarity. So it's clear that if you use this kind of circuit, you should have a ground connection. Seems like it's leveling off at around 4.5 volts. Now, I'll try a little experiment. I've connected a small buzzer to the circuit. The current voltage is 460 millivolts. One thing we notice here is that without the ground wire, the capacitors don't charge well. So I'll connect my body again, same as before, and look at the voltage. It's jumping again. We've now reached 1.8 volts. Now I'll attach the positive wire to the positive terminal of the buzzer. We should hear a buzzing sound. I'll bring the mic close so you can hear. Here it is, it's going a bit higher. Yes, 4.5 volts still, and I'll bring it closer since I don't think the voltage will go up too much. And here, see the drop in voltage. If I keep it connected, nothing happens. Once I disconnect it, the voltage starts rising again. And once again, I'll connect it. Let's wait and allow it to charge properly. Okay, I think it's ready. And here, go. The voltage drops to 4 volts. Next, I've connected a small LED. It's green, and I'll charge it again using my body as ground. Let's try lighting the LED. I think it's charged enough. Now I'll touch this clip to this one. And go. There's a blink. I'll do it one more time, just in case you missed it. This time, notice how the voltage on the meter drops. Go. See. Down to 1.945 volts. Now the LED isn't lighting anymore. It's at 2 volts, so it should glow, but it's not increasing. Oh wait, there's a very faint glow. This time I won't disconnect the LED wires, just touch it with my hand. I think you can see a faint glow on the LED. It is lighting, just very dimly. Let's try touching this point. Same result. How about this one? Same. So, as you saw, this circuit managed to produce about 4.5 volts, which is impressive. Many of you might think that 4.5 volts could be used to charge phones since they use similar voltage. But no, this can't power much because the current output is very low. Now, getting back to the main reason I made this video. This circuit and the whole idea behind it relates to Maxwell Chikumbutso. Many of you might have heard of him. He claims to have made a device that can capture radio frequency energy and turn it into usable electricity to power houses. The claim says about half a megawatt of output. From what I've researched, I don't believe that's possible, because the setup needed to achieve that would be massive and not practical. This small setup is producing less than a watt. Just milliwatts, so you can imagine how difficult it would be to make anything more powerful. He also claimed to have built an electric car that never needs charging and can run forever using radio frequency. Again, I don't think that's possible. Where's the ground connection? Without that, we won't get much power, and the setup would be bigger than the car itself. Also, the kind of towers needed, only broad-spectrum channel towers nearby can provide usable energy in watts. So, it's an impractical design, not useful for real power, but yes, you don't pay for electricity when using it. So I'll call it a free energy source, but not entirely free, because it's still converting radio frequencies into electrical power. And that's the point of the video. I don't believe Maxwell Chikumbutso's claims. His patents were denied because they were for perpetual motion type inventions, which don't get approved. And according to my research, his house still uses regular electricity and he pays bills. So that's all. Bye bye.